Hello everyone, welcome to my chemistry channel BL Das Short and Sweet in Chemistry. Now I am going to the topic that interconversion of alkene and alkyne. Lower alkene to higher alkene and higher alkene to lower alkene. Like this, lower alkyne to higher alkyne and higher alkyne to lower alkyne. Now see the first question, this is the part 1. Before that I have explained how the conversion takes place, alkane, alkene, alkyne. Now in part 1, say it is part 1 where I want to explain alkene and alkyne conversion. And first question, ethene to propene. What is ethene? Ethene is the double bond having two carbon, where CS2 double bond CS2 is the structural formula and CS to C2H4, that is the general formula. Propene, CS3 CS double bond CS2, this is the structure formula propene, where it contains 3 carbons and 1 double bond. That position is 1 2 3. After 1 there is a double bond, so you can say 1 propene or simple propene also. Now here the question you can see, ethene is 2 carbon and propane is 3 carbon. That means increase of 1 carbon. How it will take place? That is ethene CS2 double bond CS2. If you treat HI, then addition reaction takes place, and here comes to hydrogen, and this hydrogen comes to here and this I comes to here, and what is the product here? CS3 CS2 I, ethyl iodide, which is common name. And what is the IPC name? Iodoethane, iodoethane. KCN, potassium cyanide. It is the only chance, so it is the only reagent where you can increase carbon easily. So I is replaced by CN. CN means cyanide ion, cyanide. That means CS3 CS2I, KCN, Ki is the byproduct. And what is remaining? CS3 CS2 cyanide, CN. Then what is the name? Ethyl cyanide, or you can say ethane nitrile. So ethyl cyanide, when here hydrogen is added, that means you can say here reduction takes place, or you can say addition of hydrogen takes place. Actually here you can say reduction takes place. Then what happened? 2 hydrogen, out of 2 hydrogen, 1 comes to this carbon and 1 comes to this nitrogen. That addition of hydrogen, or you can say reduction. Then what is the product? CS3 CS2 as it is. Then C, this C changes to CS2 and this N changes to NH2. That means C changes to CS2, N changes to NH2. Then how many carbon atoms here now? 1 2 3, 3 carbon. And before that 1 2 in hydrocarbon 2 carbon, and here in hydrocarbon 3 carbon. What is the name? Propyl. CH3 CH2 CH2 propyl. Propyl NH2 mean amine. Propyl amine, or you can say 1 amino propane, or you can say propanamine. Again see, common name propyl amine, IPS name aminopropane, but actually nowadays you can say propanamine. In one position there is no problem, and you can simply say propanamine. This propanamine, that means amine, primary amine. What is primary amine? If NH2, primary amine. Primary amine when react with nitrous acid, remember nitrous acid is not available in lab. That is why you will add NaNO to sodium nitrite and hydrochloric acid. So you will get here that means the chemical reaction. One should remember, primary amine when reacts with nitrous acid, it gives corresponding alcohol. 3 1 2 3. 3 mean propyl alcohol, or you can say propanol. IPC name what is that? Propanol. What is the common name? Propyl alcohol. Any alcohol, if you treat PBr3, phosphorus tribromide, if that means here this OH is replaced by bromine. Remember 1 2 3 1 2 3 you put as it is, but OH is replaced by bromine, so this is called bromopropane, alcoholic OH. So CH3 CH double bond CH2. Now here this hydrogen and this bromine that will react and gives us a byproduct, and what is remain? CH3, CH, CH2. What is that? Propene. Again see, it is very very important. You take ethene plus hydrogen iodide, it gives alkyl iodide, Caesian, alkyl cyanide, hydrogen, that means reduction, C changes to NH, C changes to CH2, sorry, C changes to CH2, N changes to NH2. Now it indicates primary amine. How many carbon? 3 carbon, propyl amine. Primary amine when react with nitrous acid, it gives alcohol. Alcohol when treated with PBr3, it changes to OH replaced by bromine. Here OH replaced by bromine, and so bromopropane. Bromopropane, you know, this reaction is very very important. Alcoholic is never write aqueous KOH, because aqueous KOH the product is alcohol, whereas alcoholic KOH the product is alkene, and this is very very important. So you should remember almost all reactions are used here. I think it is clear. Again see, any doubt? Hi, Caesian, HNO2, PBr3, alcoholic acids. There are 5 reactions are used. You should remember. And next come to Ethyne to propine. Ethyne mean eth 2 carbon. Wine mean that containing triple bond. Propine mean, prop mean 3 carbon. Wine mean triple bond. So what is the formula? CH triple bond CH to propine, CH3 C triple bond CH. Now here you take ethyne. Ethyne means CH triple bond CH. Now question is, here you will put that mean one CH3 group here. Instead of H you will put CH3. Then what to do? If you are sodium, simply either this hydrogen or this hydrogen first replace by hydrogen with sodium. If further treated with sodium, these 2 hydrogen are replaced by sodium. Now only 1 hydrogen sufficient for the answer. See here, this hydrogen replaced by sodium. So what is the name? Sodium acetylide. Sodium acetylide, or you can mainly the common name is very famous, sodium acetylide. And if you treat here CH3I means methyl iodide, then what is the product? The sodium that is replaced by CH3. Then you are getting answer, propine. If further, if the question is butane, again this hydrogen replaced by sodium and this sodium is replaced by CH3, then you will get butane. But the question is not butane, the question is propine, CH3 C triple bond CH. So again see, ethyne treated with sodium, first 1 hydrogen replaced, that is sufficient, and CH3I, the nitrogen replaced by CH3, then you are getting the answer, propine. I hope it is clear. Ethene to propene, 1 carbon increases, ethyne to propine, 1 carbon increases, but it is alkene and it is alkyne. And here so many reactions are involved with alkene with HI, iodide with Caesian, Caesian with cyanide with hydrogen, HNO2 alcohol, alcohol with bromine, bromoalkane with alcoholic acid, alkene. This is the main important reaction of alkene. I hope it is clear. Next we will see other reaction, other conversion where alkene and alkynes are involved. Here we will see ethane converted to butane. The conversion of ethane to butane. Then what is ethane? What is butane? Ethane, butane both are that is containing triple bond. Ethane where there is only 1 triple bond and 2 carbons, and butane where there are 4 carbon and 1 triple bond. Actually if you say it is 2 butane, how? 1 2 after 2 there is a triple bond, so it is called 2 butane. Now you can take ethyne, then sodium. What happened? The hydrogen is replaced by sodium, and again you take one other sodium, then also here replaced by both hydrogen by sodium. Now again see, one hydrogen replaced by one sodium. So this is the compound sodium acetylide, and next is this sodium, again it will give this one as disodium acetylide. And now these two sodium which is present in acetylide, they are very active and easily they can be replaced, substituted by CH3 methyl group. That is why, because we required 2-butane, that is why here you can say these two sodium are replaced by methyl group. So CH3C triple bond CCH3. That means what is your aim? Ethane should converted to butane, ethane having 2 carbon and butane having 4 carbons. And how we will increase? Simply the hydrogen which is present, generally ethane react with sodium easily and the hydrogen replaced by sodium. The sodium can be replaced, can be substituted by alkyl group by alkyl halide easily. One methyl iodide, this is replaced, the sodium is substituted by the methyl group, and here the sodium is replaced by methyl group, that means methyl is substituted by sodium. Then what is that result? This is CS3 C and triple bond CCH3, that is butane or 2-butane, and it is ethyne or acetylene. Now come to propine to ethane. Next, what is the next question? Propine to ethane. What is propine? Propine means triple bond and having 3 carbon. To ethyne. Ethyne means double bond having 2 carbon. See, 3 carbon changes to 2 carbon. Decrease of carbon. Here what happened? Increase of carbon. And increase of carbon, 2 carbon to 4 carbon. And here what happened? 2 carbon, that means here 3 carbon to 2 carbon, decrease of carbons. Then how can you do decrease of carbon? That means here specially this is propine, Lindlar catalyst. What is mean Lindlar catalyst? I will tell now. First remember, if you apply Lindlar catalyst, they very very important, and here immediately it gives to alkene. How many carbon? 3 carbon. So 3 carbon triple bond changes to 3 carbon double bond. That means triple bond, if you want to change to double bond, then immediately you can add Lindlar's catalyst. Now, but you require ethane. Here how many carbon? 3 carbon and having double bond. Now, here question is decrease of carbon. Here 1 carbon to be decreased. Then what happened here? The propene, you are taking propene. This is called propene, and here you take ozone, not oxygen, ozone. Then what happened here? You take ozone and water. Ozone means ozonide, the double bond. Alkene undergoes ozonide. That means when react with ozone, it gives ozonide is a complex product. But when it reacts with water, it gives corresponding aldehyde, ketone, maybe formaldehyde, maybe acetaldehyde, or maybe ketone, according to the number of alkyl group, according to the number of hydrogen. Since this side methyl group is there, you can think yourself CH3CHO, one oxygen will come and hydrolysis will take place. Water, hydrolysis takes place, and ozone, ozonide, ozonolysis takes place. Now CH3CHO, what is the main product, and the side product, that is formaldehyde, that is not required here because it is only a minor product. Major product CH3CHO. Now here you can see how many carbon atoms there. First 3 carbon, and here how many carbon? 3 carbon, but 3 carbon having triple bond. When Lindlar's catalyst, the triple bond changes to double bond, and after that ozonolysis and hydrolysis, it gives acetaldehyde, or you can say ethanol. What is the common name? Acetaldehyde. What is the IUPAC name? That is ethanol, NaL, NaL. If OL, that is alcohol. Then if you take PCl5, acetaldehyde, then since one oxygen is there, that is divalent, that is why two chlorine are replaced by oxygen. You know oxygen is divalent, that is why two chlorine that is replaced by chlorine. Sorry, two chlorine is replaced by the one oxygen. So this is the product CH3CHCl2. What is the name? CH3CHCl2. Actually it is the house of ethane. But two chlorine are replaced. So it is called dichloroethane. What is the name? Dichloroethane. Then alcoholic KOH. Alcoholic KOH, it gives, any bromination or chlorination, then it react with alcoholic KOH, gives the corresponding, if two chlorine, two bromine, then it triple bond. If one chloro or one bromine, then it is double bond. Since there are two chlorine atoms, that is why it gives acetylene, or you can say ethyne. I hope it is clear. The aim is decrease carbon atom by Lindlar's. The triple bond changes single bond, double bond, and ozone and water, ozonolysis and hydrolysis give acetaldehyde, that is ethanol. PCl5 oxygen is replaced by 2 chlorine. Alcoholic KOH, 2 chlorine replaced by OH. Then after that, here on heating, it gives ethyne, the main product. Then question is, what is by Lindlar's catalyst? Heterogeneous catalyst. It is a heterogeneous catalyst. What is heterogeneous catalyst? That means homogeneous means same type of composition. Heterogeneous means different type of composition. See, palladium on calcium carbonate or barium sulfate. Now you take palladium and pass over your calcium carbonate and barium sulfate, and after that you should make poison this compound with different forms of lead or sulfate. And here what to do? The palladium on calcium carbonate and barium sulfate you passed, and after that it treated with different forms of poison, lead and sulfate compounds. Then after that it is called Lindlar's catalyst. Remember what is Lindlar's catalyst? It is heterogeneous catalyst, palladium on calcium carbonate or barium sulfate, and then it is poison with different forms of lead or sulfate. I hope it is clear. Ethyne to butane, propine to ethane. Here you will increase carbon atoms, and this question you will decrease carbon atom, but both are very, very important for different types of exam, board exams and other different type of exams. I hope it is clear to you. Interconversion of different type of alkene, alkyne by the decrease of carbon or increase of carbon. And hope you will subscribe my channel BL Das Short and Sweet in Chemistry. And thanks for watching my video. Thanks again to all.